We have here an angle and two sides of a triangle, and one of the sides is opposite that angle. So this is the side angle configuration, which tells us that we'll be using the law of sines. Now this is the ambiguous case, so we'll want to draw a picture and get an idea of what might be happening here. So we have this angle of 30 degrees. There's a side that we don't know, and then that angle of 30 degrees. And the side that's opposite the 30 degrees is 10, while the one adjacent to it is 5. And so we've got this, oh, I'm sorry, I said that opposite, didn't I? And the side opposite is 5, while the side adjacent is 10. And so, well, 5 is pretty small compared to 10, and so it may be too short to connect down here, which means we may not have a triangle, or it may be long enough to just barely touch and create a right triangle, or maybe long enough to create two triangles in two different positions. Okay, and so we're going to figure out what that is by just applying our law of sines and seeing what happens. So this angle here of 30 degrees, let me just label, that's A and side C. So this side down here that we don't know is B, and that angle up there is B, and this angle here is C. So using our law of sines, we're going to start by finding this angle C. Okay, that's always going to be the first step you do in the side angle, is solve for the angle opposite the other side given. So our law of sines, I'm just going to use the portion here that I am actually going to find. I have sine of A over A and sine of C over C. I'm just going to use that part right now. So that's sine of 30 degrees over 5 equals sine of the angle C over 10. Now we can multiply both sides here by 10, and we get, actually just 10 over 5 is 2, so 2 sine of 30 degrees equals sine of C. And 30 degrees is actually a special angle, so I know that the sine of 30 degrees is actually 1/2. And so that gives me, of course, 1. 1 equals the sine of C. And there is only one angle for which the sine is equal to 1, and that angle is 90 degrees. So this means that this side, it does connect, because we didn't get an error there, and it connects at a perfect right angle. So we get a single triangle here, a single triangle, and it's a right triangle. So now we have that angle C. We can solve for the angle B by using 180 minus those two angles. And of course, since this is a special right triangle now, we know that that's going to come out as 60 degrees. And finally, we can solve for side length B. And again, because it's a right triangle, we have multiple techniques available to us. I'm just going to use the special right triangle that I know, and that's that this is going to be similar to a triangle with side length of 1, 2, and root 3. And so B over 5, okay, B over 5 would equal the square root of 3 over 1. And so B then is equal to 5 times the square root of 3. And of course, that's just one way of approaching it. We also could have done the Pythagorean theorem. And that's our solution. We've got our side length B, and then our two angles that we didn't know, and we've got our triangle.